I saw him. I saw him. Yes, John, do you hear me?
Yes, I do. Did not realize that you had a different link today. Sorry.
Okay. Okay, John, we see you. I think you cannot see me, but you hear me. You hear
I
me?
do. I do. Yes.
Great. We are so glad to be in live with you. Thank you very much for your time. In front of you, you have a very nice room with a lot of Moroccan people who are very glad to listen from you.
Okay. Well, I'm ready. Thank you. Thanks for the connection here.
Yeah. You heard the applause of the people. So first, can you tell us which are the most important discovery made thanks to the James Webb Telescope?
Yes, of course. The most important thing that we set off to do was to see the first objects that grew after the Big Bang. What are the first galaxies, the first black holes like? And we have seen them as far back in time as we think we can see them within a few 100 million years of the beginning of the expansion of the universe. So very, very close to the first moments as far as we can get. So as you know, we're looking back in time by looking far away because you use the light travel time to take care of that. We've also looked inside the atmospheres of planets around other stars. We have many planets that go in front of their stars, and sometimes the light from the star will go through the atmosphere of the planet on its way to our telescope, so we can do a chemical analysis of atmospheres of other planets. It's the first time that we've really been able to do that for interesting planets with the infrared capability of the Webb. So we've seen different atoms and molecules like sodium and potassium, carbon dioxide, carbon monoxide, methane, ammonia turn up in the atmospheres of other planets. None of them, however, are like Earth as yet. We do not yet have observations of planets small size and the right temperature to be like Earth that also have an atmosphere. So we're looking at our own solar system, of course. All the planets from Mars on outwards can be observed with a Webb telescope, and we've seen beautiful rings around all of the outer planets. We've seen auroras on Jupiter. We are observing Titan, which is a satellite of Saturn that has an atmosphere of its own. And we are even getting ready to go back with a helicopter in, I think, 2034 to land on the surface of Titan to see what is the strange and exotic chemistry out there.
Oh, and I know you are not a man of speculation, but what are the probability for you to detect a real sign of life with the technology you just described, with the chemical analysis of the atmosphere of the planet?
Right now, the signs of life that we would hope to find on a planet like Earth would be water and oxygen. Those are the strongest signs, and we don't think we can do that because the planets we can observe do not seem to have an atmosphere. That's because of the particular kind of stars that we are able to use this for. So I don't think we're going to find signs of life that way. Closer to home, of course, we would be thrilled if we can send a probe to another place in the solar system and discover something that really looks like life, either the chemical signature or even the physical appearance of cells on the surface of another object. Mars, Titan, other places in the solar system that have oceans, but are really difficult to access.
Yeah, you just told us that looking in the past is looking far in looking far in the space is looking far into the past, but you cannot look to the Big Bang. So you told me one day that like when we go, we have a tendency to go to the zero, but zero is outside the system. For you, the origin of the universe is outside the universe, you told me. Like when we go to the zero.
Yes. Of course, we have many speculations about this. We see that the universe is expanding now. We imagine back in time to when it was very hot and very dense. And then when we imagine far enough back in time, then we say, we really don't know the laws of physics that ought to apply at such extreme conditions. So we're guessing. The popular guess is that there's something called inflation, very, very early in the first sub-microseconds of the expanding universe that causes exponential growth of the universe. And that's responsible for the structure that we see today. If this is a good idea, if it's true, then it's possible that there could also be other universes that we would never know about either. Because, of course, the universe that we see is everything that we could possibly see by definition. So there's a lot we could not possibly know, and I think we should not be too surprised if there are things that are not knowable for human beings.
Yeah, you mentioned inflation theory and this other dimension, but can we say that our universe, even if there's a lot of debate about its origin, about the bouncing theory, is not self-sufficient, that it does not exist by itself, because it's including or something else, or it came from something else, our universe?
Well, I don't know the answer to that question. It just seems to me that we see what we see, and then we interpret it. So we don't have any real way to interpret what came before. Of course, we try, but I don't think we can.
But you know that, of course, much better than me, that the universe is accelerating, so that means no big crunch, theoretically. And I think it's something of significant philosophical importance, because that's a very important result, that this universe will not make a big crunch, no?
That seems to be true. For many generations of astronomers, we knew the universe was expanding, but we thought maybe it would stop and turn around and fall back in again to make a big crunch. And then maybe it would bounce and start over again. So it's certainly a good idea. Right now, the evidence is that the acceleration continues, and so it will not turn around.
And you told me that, of course, not only quantum mechanics, but also chaos theory has liberate us from materialistic determinism. And you can comment a little on this?
Yes, pretty clearly the atoms have no sense of meaning all by themselves. But when we look at our lives, we see a very complex social world around us. The biological world is incredibly complex. And it is, it's not possible to say whether it's deterministic exactly, but it's extremely complex and not predictable, which is a little bit different from deterministic. It's completely not predictable. We have no way to anticipate very far into the future what is going to happen. So that is a remarkable result of modern thinking, that even if the atoms were completely deterministic, as Isaac Newton and his successors started to think, nevertheless, the practical importance is that it's not possible to know.
We discussed together in the past your interest for the theory of emergence. We discussed Stuart Kauffman, for example. And do you think that emergence, the idea that at a higher level cannot be explained with the property of a lower level, is a possibility to find meaning in the universe?
Yes, I think quite clearly we have meaning. We give meaning to the world that we are in. I think it's meaningful to get up and have my breakfast and talk about science with you. What we're doing is something that never could have been predicted a century ago, even a few years ago. So that's what we call an emergent property, that we are able to do things in a complex world that completely unpredictable from the basic laws that go into that world.
And in front of the extraordinary discoveries of last 50 years. Do you think science must be more humble because the project of science was to explain at the time of Laplace, to explain everything, and now perhaps science has to be a little more humble? No? What do you think about this?
Well, it was clearly not possible ever to explain everything. Even the idea that the world is deterministic and that all the atoms would follow their trajectories according to the laws of nature without any intervention, that even if it's true, it means that you still cannot know what the future will be, because that future is just too complicated. Yeah, as we see, human beings have a genetic code which controls our future in ways that we do not understand. So there's an accumulation of information in our bodies and in all other living things about how to cope with the world. So we are now looking at a world filled with active agents. You and I and all the cells and all the bacteria, they all are making decisions of some sort every day, all day long, about how to survive, how to do the next thing. So this is a world of complexity that is not currently explainable by science at all.
Yeah, very interesting. And so you also have suggested the existence of a non-material world, and in your mind, it's not a divine world, but it's the world of not only thought and ideas, but also the world of mathematical object. Can you develop your idea of the fact that there's a non-material world in different dimensions?
Yes, I think it's pretty clear that ideas are non-material. Mathematics is non-material, independent of the atoms of the universe. If we imagine that conscious beings in another planet would discover mathematics, they would find the same mathematics, we think. So that's something that exists in a completely different way from atoms and molecules. The patterns that we see when we say, oh, this line is straight, that's something that we interpret as something about the universe, but it is not it's not so much a property of the atoms themselves. So we see patterns, we see meaning, we tell stories, we have mathematics. All of these things are non-material. And I think that even the ancient philosophers 2,000 years ago would have said so.
Yeah, we have also spoken together about this fantastic case of Ramanujan, who was capable to reach, in some way, some mathematical formula that 90% of them was right without demonstration. It seemed that it inclined us to believe that the human mind have other dimension and can grasp sometimes some sort of other reality, no?
Yes, yes. He had the ability to see mathematics and to make mathematics in his mind in a way that almost no other human being has ever had. So we are amazed at what he's done, and he certainly is showing us that mathematics is a different thing from atoms and molecules. So I'm still astonished at what he was able to do.
So for you to conclude, what is your way to find meaning in the universe with your quest of understanding and with your work as an astrophysicist?
I find meaning in everything that I do, from getting up in the morning to talking to my friends, to talking with you, to writing, thinking and conceiving of ideas, to inventing new ways to make telescopes. All of these have meaning to me, and I think they do in society. So that's where meaning is for me. It is looking into the daily life and saying, this is important to me.
And to finish, what are the most important progress or discovery you can imagine in the 21st century?
Oh my goodness, I hope that we will understand quantum mechanics a little better. We know that it's true as far as we can tell, and it has however many mysterious features, especially the quantum entanglement features that people have been working on. In astronomy, we've discovered two strange mysteries. We know that there's something called dark matter and something else called dark energy, which have observable effects, but we cannot see them in the laboratory at all. I'm hopeful that eventually we will find a way to understand them, even if we can't measure them. And those are the biggest mysteries. Eventually, we hope to understand whether space-time is actually subject to quantum fluctuations. We have been hunting now for many, many years for a theory of quantum gravity. And none of the ideas have worked out very well. So the answer is we don't know. But eventually, I would like us to have a theory of that. There are even ideas that perhaps the laws of nature and the particles of nature that we see are the consequence of some mathematical story that we don't know yet. So, for instance, what if the fundamental constants of nature, like the speed of light and the fine structure constant, are actually geometrical in some mathematical description? That would be remarkable. So I think there are many surprises coming to us in fundamental science.
Thank you very much, John, for your time. I know that you was in Marrakesh long time ago, so I hope you can visit us with Cheryl next year.
Well, thank you very much for your very kind invitation, Jean, and we'll hope to do something like that.
Okay, thank you very much again. Goodbye.
Thank you. Bye-bye now.